Hey guys, I'm here with Jackie. We're at the University of Dayton low speed water tunnel. Just kidding, all water tunnels are low speed. So this is the water tunnel. So we're going to show you a little bit how to operate it today. The first thing you need to know is how to turn it on, and we'll show you that. So when you walk in the door over here, so you'll walk in through the door and then you'll come on over here to the left, and we've got this power supply box. All you got to do is flip it on up. And now the water tunnel has power. You're good to go. Just a quick side note for you. This is the filter. This is just used to clean the water once a week. Just got it on and off, but nothing that important. Okay, so once you got it powered on, this is the control meter. This is what you use to control the flow rate of the water. If you look here, you've got the up and down arrows. You can use these to change the flow speed. So you'll see right now it's blinking, and this is the flow. So our tunnel operates between 12 and 60 on this. So in order to change that, what you do is you come over to this right arrow, and you can select between all the digits. So say, for example, I want to do 38. I'll just go to the 1, change that to a 3. And then if I want to do a 5, just go over 1 and change it down to a 5. And so you don't really want to turn it on too quickly, because otherwise water might splash over the top. But 35 should be fine. So you'll just go ahead, hit enter, and then you can hit run, and that'll turn it on for you. And now you can hear it firing up. And then if you look, you'll know the water level is changing. So, one of the really cool things that we can do in the water tunnel is dye visualization, and that's what this tube emphasizes. So if you look over here, this is how we control all the dyes. So currently we just have yellow set up, but there also is space for blue, red, brown, and green. So to control these, we have compressed air, and you can turn on the compressed air through this valve. So you turn that on over. And then this knob here is what you use to control the actual pressure to the system. It says the max is 15 psi. However, you really want to set that to around 5. And to do that, you can use this knob. So to unlock the knob, you simply pull up, and then you can control it up and down depending on the way you spin. And then to lock, just push back down. And then if we come back over here to the dyes, we have these switches. Basically what this does is it turns it on and off. So you can turn this to the side to turn it on, and then this controls the flow rate too.
That's on.
Oh, my bad. That is on. It was messed up. My bad. That's what we have Jackie for. And then you'll turn this knob as well to control the flow rate. So you don't need to turn it too quickly. And if you look now over there, you can see that the dye is on. The more you turn it, the more flow you get. And so one really quick thing is when you're turning this on, you want it to match the flow rate of the water. So you want about 1 inch of laminar flow for a good dye visualization. Cut it. Yep.
Yeah, cut it. Hey guys, Jackie here. So now we're gonna introduce how to change the dye system and how to run the water tunnel. So the dye system is here. So whenever the dye is running out, if you want to change the dye, you're gonna switch on, switch to off. So make sure both switch are off. You're gonna rotate this thing off. Why is this so bad? Oh. All right, it could have some pressure coming out because it's pre-pressured. So rolling this thing off here. So the dye will be place it here, down here, so the fluorescent dye here. So one thing you have to remember is that the ratio of the dye to the water is around 2,000 to 1. So you don't want to pull a lot of dye into this. So usually when it's empty, we'll just drop a couple drops of dye in there and then fill it with the water. So now the dye level is good. So when you add the dye in there, you gotta replace, put it back in here, and then rotate it back here. You gotta do it pretty tight because you don't want any leak of the pressure. If there's any leak, the dye won't come out. So, all right, so now you're gonna turn on the the switch so that the air pressure gonna supply everything, and now the dye system is ready. Then we need to know there is a black light, which is a UV light, placed down here. So the fluorescent dye will be seen more clearly when we have a UV light. So go ahead, we're gonna plug in the plug here, so the UV light will be turned on here. So we have a couple models here in the wind tunnel. We have the old car models here, which we have inserts. We can mount it on the interface. We have wing models. Any wing models that we test in the wind tunnel can be tested in here. So this model is a specialized model. It has a couple holes in here, so the dye will be supplied on the bottom. It will go out there. And we have a couple airplane models. We have the huge SR-71 here. That's the F-18, and we also have the Spitfire. So the F-18 Spitfire model has redesigned it for the water tunnel flow visualization. So if you see here, it has the little holes for the dye to come out. So when you mount the model in the water tunnel, there will be holes here for the dye supply. So you're gonna plug in the dye supply and then turn it on. You can see the dye coming out of the model. So we have a couple models to select. So if you select your model, if you go up here, there is a rotary stage here that we can change the angle of attack. We also have an 80-20 rail that the rotary stage is mounting on. So if you, anytime you want to put the model into the water, you're gonna have an Allen wrench to lose this, the 80-20 and lower it down. So you're gonna hold the 80-20 when you loosen it so that the rotary stage doesn't get to the water. If it gets to the water, against it won't be happy because you will literally destroy anything. So usually always change the left one first because the right one has a stopper on the right, so it's kind of like the safety insurance that this thing doesn't fall down too much. So when you had everything in position here, now we can see the model is mounting in the water now. The second thing is you're gonna make sure your dye injection is on the same height as your model. So now we're gonna put it a little bit higher. So this is so fun. So now you need to make sure it's on the right place here. More. So now it's good. So we're at the same level of the model. So when everything's ready here, we're gonna turn off the light so that we can see the fluorescent dye much better. So, all right, go ahead. So when we've set in the model and everything ready, we're gonna turn on the tunnel. So we hit run on the control panel. The tunnel will start running. So you're gonna wait 10 to 20 seconds until the tunnel is steady. So usually for flow visualization, we do the number on the control panel is usually between 18 to 24. So the maximum that water tunnel can go is about 0.3 meters per second at 60. So it's pretty linear. So it means at 40, it's about 0.2 meters per second, and 20 is 0.1 meters per second. So you can estimate the velocity, and then you can calculate the Reynolds number of the water tunnel. So now, the first thing we need to do is to match, as Neal mentioned, is to match the flow. So we need an inch of laminar flow. We're gonna turn on the knob, and then see the flow coming out. So that's kind of like a turbulent flow. So we're gonna reduce the flow rate to something like this, and now we're seeing about an inch of laminar flow coming from the dye injection. So now we're gonna place this in front of the model. Now we can actually see the model, the flow around the model here. And then if you want to pitch up the model, we can just use your hand to pitch it up a little bit. You can actually again see the flow separation a little bit at the end, and then the recirculation. This model actually has a airline and flap, so if you want to pitch it down a little bit like this, you can actually see the control surface on this. So you can see the control surface if you can also apply the dye at the lower surface of it, which is pretty neat. So you can also have a high angle of the control surface deflection. So if we do this and then going back, so we can have the control surface pitching down here. Now we can actually see how the flow going around the flap, which is really cool. So we have a lot of wing model that we can use for the water tunnel to see the flow around an airfoil. We also have airplane models, as we mentioned. So if we want to change it to the airplane model, we're going to switch off the dye to off, and then take this model off first. So just rotate it off. It will come off. Don't lose this. Don't lose this. I should stop saying anything. When you plug in the dye tube and you can turn on the dye, so you can actually see there is flow coming out of the wing. Again, you need to adjust the flow coming out of the wing and then see a good flow here. So this should be pretty good, like this. So you should see a pure laminar flow coming from the wing, and then you can also change the pitch angle of the model. So you can yell and you can change the pitch angle like this. Up and down, so you can actually see. You also yell the model, so you can see the wing stall. Since the Spitfire has a elliptical wing, the whole wing should be stalled all at once. So you can also design other different type of models for the water tunnel testing if you want. So that will be everything for the water tunnel. Have fun.